Hello everyone and welcome to Handmade Hero, the show that we code a complete game live on stream. We took a week off because I was fairly dejected after last week's stream, where not only did Visual Studio break, but Nsight also broke, and the installation of the drivers that Nsight requested not only broke the program we were trying to use, but also broke our old ability to use Nsight, so everything was in complete shambles. Now, amusingly enough, not only have I had Microsoft contact me back when I filled out that survey on stream about what they could do to fix Visual Studio, I seriously doubt that much will get fixed in Visual Studio because it's not the first time Microsoft has asked me, and so I don't think it'll be the first time that they ignore me. But this time around, NVIDIA also contacted me about the problems with Nsight. They were very nice about it and apologetic, and they asked me if I could try doing a couple things because they weren't sure they were understanding what was happening. They actually looked at the crash dumps, which is more than I can say for Microsoft, and they were saying that the crash was occurring in a call to wiggle get proc address, and it was occurring inside the old driver. Now this is very unusual. I don't really understand it because it shouldn't be occurring inside the old driver since we installed the new one and the new one said it completed. But it raises the question about whether their installer was messed up and maybe something weird happened. So at the beginning of today's stream, I would like to do them the courtesy of gathering some information for them because in my opinion, if someone is willing to help get the development environment working, then I am more than happy to help them and hope that they can. So I'm going to go ahead and just take a look at some of those things they asked me to take a look at and see if we can figure out any more information about what actually happened. They downloaded the source to Handmade Hero and were unable to reproduce it. So again, like I said, the NVIDIA team definitely taking an interest and really trying to fix things, which I feel like they should be commended for. I really do appreciate that someone took the time to try and figure out what was going wrong. So let's see if we can give them some information to help here. I'm going to click on System Information here. So I'm able to verify, at least as far as the control panel is concerned, that the driver version is in fact the one that we thought was installed. So I'm not sure what's happening on their end or why they're seeing that crash report reporting as being in the old driver, because it does seem like the new driver at least is the one that's happening here. Now, one thing that could have happened is maybe the machine has rebooted since then. Maybe it didn't take the first time, maybe it took now. So maybe let me try running our program again. Let's verify that it still crashes, send them another crash dump. Hopefully that is at least a second benchmark point. And then they also said installing the driver clean might help. Or maybe there was something that got left on there. They couldn't tell because, again, they said they weren't really sure why it was getting a report from the old driver version. Because, of course, they could see on stream that we installed the new one. So, again, I have no idea what was going on there, right? So let's go ahead and try Handmade Hero again. This is the thing we made for it. Now, presumably, unless it was the case that the old, there was a reboot or something that helped fix it. In this case, what we should see is the same crash again. If we don't, then it fixed itself. But no, it's definitely crashing. Let me go ahead and tag this here. This is a crash report with the NVIDIA control panel affirmatively confirming that we are on 391.01. I think that was what it was. Let me just double check that. Don't want to accidentally send them the wrong number. .391.01. So hopefully they can take a look at that and tell us what's going on there. I don't really know. I don't know if save mini dump is something that's worth doing here, so I'm just going to do it. Initial, or let's say this is mini dump 00, right? That way, if they need these mini dumps, I don't know if the send report sends the mini dump. I assume it does, so I don't think we need to save that, but I don't know how their crash reporting tool works, so figure better safe than sorry. Right? All right. So now that we know that that's what's happening, again, we can try just a couple simple things. I'm going to go ahead and reboot the system with a clean install of the driver, and we'll see if that helps. Again, I'm assuming that it won't, but we don't really know, right? So let's go ahead and try that. I did, when we installed it the first time, I did save, just perhaps prophetically, the driver installation that we used. So if I double click on this here and we go ahead and let it run, here is the 39101 driver just getting installed fresh. This time I'll do the exact same install that I did, but I will go ahead and click on the clean install button. Hopefully that will wipe everything else off of the machine that might have been on here that could still be causing some kind of a weird old driver compat load thing. I don't really know how they were getting a crash jump from 388. It seems kind of unlikely, but you know, I don't know how their system works, so maybe there's some explanation for that that I can't fathom, right? Coffee time. There are very few things in the world better than coffee. I just like to point that out. One of the things that I figured out kind of later in life, hold on a second, let me make sure we check that perform clean installation. We don't need any of this stuff. So I think just those two and clean installation, that should wipe everything, and we should be left with only the 391 driver and the HD audio driver, which we need for the streaming setup. I'm gonna go ahead and hit next, and off it should go. One of the things I noticed is like coffee for me is sort of like, it's definitely like a psychoactive drug in a sense. I mean, obviously it is for everybody, but the same sort of effects that like ADHD people or whatever say they get from like Ritalin or Adderall or things like this, I totally get from drinking just a little bit of coffee, as far as I can tell. So like the difference between me drinking coffee once a day, just like 1 or 2 shots of espresso, so like 100 milligrams, 100-ish milligrams of coffee, of caffeine, let's say, per day, the difference in my level of productivity on a concentrated task is nuts. Like, it's just massively different. I think I probably would have scored like much higher on my SATs, for example, if I had just drank some coffee before taking them. It's kind of funny. Like the difference is kind of massive, and it's generally because like my brain kind of has 2 modes, and they're sort of controlled by coffee. Like one is very whimsical and imaginative, and one is like can be more concrete and focused on technical details. And coffee generally picks which one of those I'm in, or I should say caffeine in this case, I suppose. And so in a lot of cases, wait, did that just kill my... So this has killed... My monitor is off now. My monitor, it only came back on the HDMI output. I suppose that's fine. I will go ahead and just use the other one, but you're going to lose audio in a second. So I'm going to stop talking because when this closes, Hello? Can you hear me now? All right. So that was a clean install in all possible ways. Like everything was removed. So it's about as clean as it gets. And so we now have an installation. It was running Microsoft Basic Display Driver before. Now it's running 39101, right? And I'm going to try to install Nsight Graphics, which is this right here. And this is the best we can do. We can't do anything better than this. It's a clean install. We verify the driver number. And so if it crashes this time, I got nothing. I don't know what's going on. Because there's really nothing else we can do beyond that. I don't know what this is right here. Doesn't seem like I can get rid of it. Microsoft has decided that you cannot unpin this from the taskbar. Dear Microsoft, maybe you're confused about what unpin from taskbar means. Believe it or not, unpin from taskbar doesn't mean leave it on the taskbar just like it was before. I love this. Do you want to allow this app to make changes to your device? 9b76d.msi. Like, of course the average user is going to be well aware of the security implications of Microsoft asking them if 9b76d.msi should be given permission to make changes to the device. They just make me laugh so hard with their ridiculous security stuff. Would you like to allow a program you don't recognize to do something we won't tell you what it is? Yes or no? Windows is such a pile. All right, so we have now reinstalled Nsight Graphics, at least in theory. Unfortunately, the old Nsight Graphics thing is super confused. I don't know how we got, I don't know what's going on here. Okay, there we go. We finally got it removed. So hopefully now we can use the existing Nsight Graphics thing. I'm going to go ahead and make our drive as we normally do. There's our Handmade Hero directory. So we're back in business now. I'm going to go ahead and do Nsight. Let's go ahead and launch the Nsight Graphics tool. We probably have to remake this. Oh, no, we don't. So it saved this in some place that the uninstall didn't remove. So I can load it again. Let's launch it. And see how we go. All right. So we now have our Nsight working, which means that something did in fact go wrong with their installer. They just don't know what. I don't know what to make of that necessarily, since obviously it would be nice if it got fixed, but I suppose at this point they don't necessarily have the information they would need to fix it, which I suppose is a bit of an issue. But it does look like our Nsight is working, so that's good. I'm not actually 100% sure what we will do with Nsight here at the moment. I don't think we have an immediate use for it. We just wanted to install it, and now it is installed, so that's good. I assume that we can now do all the things that we wanted to do with... ooh, I don't know what happened here. We have crashed or something? I'm not sure what's going on there. So it looks like maybe we can't exit properly, possibly. That's not really a problem. Like, I don't really care if that's a bug or whatever. There may be something we're doing on termination that's bad. Or maybe something we're not doing. We were fussing with this a little bit to try and get it working. So it's entirely possible that we just need to fix something that we're doing busted there. But it looks like we can run just fine. But yeah, when I hit up Alt F4, maybe it's just breaking into this for some reason. Like maybe it just stops on exit like maybe that's just what it does, you know. I don't really know because we've never used this tool before. Maybe that's expected, right? So if we take a look in here, it looks like it's pretty good. Like it's got all our stuff, so that's nice, right? These are our shaders that we define in code, so it's gone ahead and laid them out for us, which is kind of nice. That's pretty sweet. We presumably can analyze some part of the pipeline if we stop and capture a frame. So maybe let's go ahead and do that. I'm going to go ahead and run this again. Is there just a run, like a command to run? I guess they call it connect. So if I go ahead and run it here, what is that? Control Shift C looks like what that is. All right. So if I hit Control Shift C to bring this up, then I can hit launch. There should be like an automatic launch, I feel like, but at least this is working here. In theory now, if I just do capture for live analysis, presumably it will capture a frame in the same way that it used to with the plugin for Visual Studio. I don't actually know, but we'll see. It seems like it's trying to anyway. It's working on it. All right. And so it looks to me like this is basically the same as the plugin, only thankfully it's outside of Visual Studio now, which kind of makes it a lot easier for us to use, so I'm pretty happy about that. It also looks like maybe this is a little bit better than the one we had, maybe because they've upgraded since then, or maybe we're using an old version of the plugin, I don't know. But it looks a little bit more full-featured, and having it full view is kind of nice as well. But this is kind of nice, and you can see here, this is pretty great, actually. You can see all of our calls just in a big old stream, which is great. And you can also see, like, I mean, you know, we talked about this, but you can see, remember I've said very many times we kind of need to use a texture, we need to do some texture packing if we want it to be efficient. You can see how inefficient this is, right? You see all these draw, bind, draw, bind, draw, bind nonsense, right? Like you don't want to do that, and you can see it happening right here as a very simple example, right? So it's kind of nice. I mean, let's say we didn't know that. You know, like maybe we just hadn't thought it through or whatever. You know, it's kind of, again, it's just a nice thing to have a utility like this where you can just see it. Now it's pretty obvious to you what you're doing, right? You can just see this and be like, oh, I didn't realize how many of those you're issuing or something, right? So again, like, you know, we kind of know some of the things that we're doing wrong, so maybe that's not as useful here. But you can imagine a lot of circumstances where, especially in more complicated graphics pipelines, you wouldn't have known all the things that you might have been doing wrong or weird patterns that may have emerged, and so it's kind of nice to be able to look at them that way as well. So you can kind of see here the frame, we can scrub through it, I guess, right? And I don't know what it's decided to color code these bars as. It looks like maybe when you stop hitting 30 frames a second, it gets red. But I'm not sure. Like, I don't know what green, blue, and red are. Does it say at all? Not really. So we've got some learning to do here because we don't actually necessarily know what these things are. Again, one nice thing about this too is it looks like if we scroll through these, we can see what the frame would be. So that's pretty cool, right? Like we can say, oh, let's go, you know, back here or something. And it looks, looks like we can sort of pop through the draw calls and see where we were drawing, you know, which is pretty nice as well. Blah, blah, blah. And then this we're pretty familiar with. Like we've seen this before. We kind of played with it before. But it looks like it's all there from the previous one, which is nice. And we can look at the different textures and so on, right? So here's one of our buffers. And so this is probably one of our depth peel buffers, right? And so, again, I feel like this is pretty cool. This will let us see a lot more about what we were trying to do there. This looks like, so this is the games window. And it looks like we've got a bunch of options here as well. So in the game's window itself, it looks like we're able to do a little bit of inspection here. Like if we want to keep running, like we do, it looks like we can stop at any time. I'm not sure what this allows us to do here. I don't know what zoom does. So that zoom looks like, let's take a look at the frame maybe. I can't quite tell. It's not very responsive in here, so I'm not sure. Like the cursor doesn't really seem to work. There it goes. I think maybe it was just capturing. Maybe? I don't really know. Yeah, because the cursor seems to work now. Oh, I see. Software cursor, hardware cursor. So yeah, this is pretty great, right? Like here's the start of the frame. You can see us like building it up, right? And now we're building up the depth peel. And now we're building up the last depth peel, right? And then we do our composite of the depth peels. And then we're drawing those guys in there. I don't know if we can manipulate this in 3 dimensions. Probably not. I don't know, maybe we can. Change wireframe mode. View render arc depth stencil. Texture and normalization options. Export capture. So I mean, yeah, like I don't, we are neophytes at the tool at the moment, so I can't really say much more about it, but it sure looks nice, right? I mean, there's a lot of stuff here that we could use, and that's just a really great, when we go to start, you know, cleaning up our graphics pipeline, which after the lighting, pretty much there's nothing else going into it. We may want to play with the particle systems a little bit, I think is the only other thing that we might want to kind of go back and revisit quickly. Because we never really quite put much in there. You know, this, you can see why this would be really handy, right? Because it allows us to really take a good close look at what we're actually doing, and it makes it just a lot easier to see bugs or room for improvement as we go, right? And it also kind of lets you see what like those depth peels look like, so we don't have to like put in lots of modes to view them. And again, that's exactly what you really want a debugger to do. The whole point of a debugger, because you could always debug without a debugger, but the whole point of the debugger is to save you time by quickly giving you access to information that would otherwise cost you development time to get, right? And so this is kind of nice. It's just a really fluid, it's pretty responsive after it captures the frame as well. So I would say good on NVIDIA. So it looks like the primary problem was their installer must have some issues. We don't know what those issues are. Fortunately, I guess they won't haunt us again for the time being, because we can just stay with this. But yeah, something's up with the install, and we don't really know what it is. But point being, we're now good to go. I hopefully won't need my little message board any further. But this is good. If I pin this guy to the taskbar now, we should be able to go ahead and get graphics debugging going when we need it, which I'm sure we will. In the near future. All right, I'll save this mini dump in case they want it. But other than that, I think we're good here. Okay, so let's see. Oh, internal static void is saying you have to close it in Nsight. So I guess that's someone confirming the thing that I was hypothesizing about how you can't close the program outside of Nsight, because when you close it, it will hold it open, it looks like. So that's probably just so that you can close and inspect sort of endgame stuff or something similar to that. All right, so someone was asking, can you summarize how the issue was fixed? So basically complete uninstall and reinstall of all the NVIDIA stuff is what fixed it, but we don't know exactly what it was. That's just what they were recommending. So there must have been some kind of a crufty situation. I don't know exactly what it was. So let's go ahead and load up our Handmade hero stuff now that we've taken care of that. and oh, I already did that. Okay. So back to our regularly scheduled program, non-graphics debugging edition. So where we were at is pretty simple. We had done a bunch of optimization work on the lighting, and honestly, I think the lighting was getting to a pretty nice place. And what we were trying to figure out was if we could get rid of cosine weighted sampling in our system by just weighting our samples proportional to the cosine in the first place. And this is just a standard sampling technique that's used pretty often. And essentially what it does is it prevents you from using a lot of your samples simply to get a known distribution that you already are saying are there. One way to look at it would be that we know that every term in our summation of the inbound lighting for a particular point is multiplied by cosine theta. What that means is that if we just blindly do random sampling of, say, the hemisphere, and we look at that hemisphere and say, okay, each one of the things that comes in is getting multiplied by cosine theta, essentially what we're doing is we're integrating two things. We're integrating cosine theta, whose integral we just know, right? We're integrating cosine theta, and we're integrating the actual lighting that's coming in, right? And so what we'd rather do is take the cosine theta integration out of the picture and just say, look, we know that we're going to integrate cosine theta into this. Let's just put the samples in a pattern that already weights by cosine theta. And that way we don't have to take account of that term, and we should converge faster on a good solution because we're concentrating our samples in places that will be highly weighted rather than concentrating our samples in places where they won't be highly weighted, which also just helps get a better answer with less samples. And so that's what we're doing right now. What we're actually seeing on the screen at the moment, in fact, if I go ahead and bring this up to full screen, what we're seeing on screen at the moment is literally just the version with no cosine weighting, where we have adjusted the samples to be sort of cosine weighted. But one of the things that we noticed when we did this is we got significantly more light than we would have gotten when we were using the system before. We had a sample that was, we had a version that was weighting by cosine samples and was using a pure random distribution. And we didn't see anything, we didn't see equivalent amounts of light. And so I am a little concerned about the accuracy of that and whether or not we need to concentrate our samples in slightly different ways, or whether we've got some kind of a problem in there where we're not quite right. Unfortunately, the number of samples we're taking is so low that we can't really count on converge in the first place. So it's not necessarily clear to me that we're really doing anything wrong, so much as just being inaccurate, which we already knew was the case because, let's face it, we're trying to simulate lighting with not a whole lot of samples, and we know that that's just not really strictly possible, right? So what I'd like to do now is take a look at how we can sort of wrap up the lighting to be, maybe to just finish up with it and move on. And the reason for that is that it's starting to be pretty good. Like, I'm actually liking the way the lighting's working. I feel like a lot of what we have on the screen right now just looks really cool to me. Like, I'm really liking the way that it feels. And it seems like a system that's fairly reasonable. There's a couple of things we may want to do to kind of get it maybe into a more shippable state. For example, one of the things that we're not doing right now that we could do is we don't have a light distribution pre-pass. So for example, right now we only do gathering, right? And the fact that we only do gathering may cause certain circumstances, like in the case of these tiny lights that are on the little hoppers here, may cause those to get undersampled. Now, it doesn't really look like it's causing much of a problem because it does look like we're getting a lot of light coming from those tiny lights. So it might be that we're just fine and we don't need to worry about it. But like, for example, these walls, I don't know how much light they're really picking up from these guys here, maybe compared to what they should be picking up. Because again, it's hard to hit little lights with these rays. And so one thing that you could imagine is putting a little bit of a bias into the system where we do a pre-pass on things that we know are illumination sources that we want to emphasize. Again, it's just straight up cheating, but it's something that lets us ensure that elements that we know are emitters get a little more attention. We can do that. We don't have to do that. Maybe we want to just remain pure and just say, look, that's not the goal of the system. I don't know. So we can do stuff like that. Another thing that we need to do is think about the performance a little bit. We've gotten it to a pretty good place, but we can probably do a little bit more there. So cleaning that up and making sure that's compact. And then finally, the biggest thing that I think we really want to do is figure out a way to make the interpolation of the lighting be a little bit more coherent. And so what I'd like to do is when we do our world building, for example, we need to be able to do something where we're going to use intelligent neighborhoods of samples to produce the final lighting. And so what I'd like to do there is we want to start looking at how we're doing our lighting interpolation. And we want to make our lighting interpolation be more of a focus. So, previously all the stuff we were working on for the most part was entirely based on computing the lighting at sample points. And that's what we've been working on the whole time. We haven't spent any time working on how we interpolate the lighting. After we stopped trying the voxel stuff, we haven't really gone and paid attention to that now that we have a good way to sample the lighting. So I think that's what I want to move on to now. And so the two main areas of focus, we'll do that. So we'll try to get a good, and we'll get kind of a final looking thing. And then we'll just move on to a few more performance optimization work sorts of stuff to make sure that we can run this in real time reasonably. And right now, we don't really do that. I think we're a little overweight because this is a fast system. And so if this system can't run it handily, then we're going to have problems because some people will want to run Handmade Hero on slower systems than this one. Even when Handmade Hero is finally out, this might be an example of a system that's a medium specification, but it's still, it's not fast enough, right? It's got to be faster than this. So yeah, that's what we've got to do. But other than that, I'm really liking it. I mean, I think the lighting, I think we did a good job. We went into it not having any idea how we would do lighting in this world, and I think we came away with a pretty cool system that captures a lot of interesting effects. I mean, I love what's going on here, right? You get this kind of blue lighting from bouncing off the walls here, and you get some nice little red kickback there, which is a blue-red kickback. And like as you move across, if you watch what happens here, you can kind of see the red kickback change. It's really nice. I mean, it adds a lot of character to the scene and helps make it feel more like a nighttime scene. This game is supposed to take place at night, and so a lot of kind of light and dark kinds of contrast, I think it really helps make you feel like you're part of that situation. So like I said, I think we've done a good job. And what I want to focus on now, I think, is to ping pong away from the actual lighting computation for a little bit. We'll come back to it to sort of finalize it, but get back into interpolation. And another reason we want to do that is because you take a look here and you've got, like, say, these trees. We have to light those as well. And again, that doesn't change the lighting equations at all. It just means we need some way of applying the lighting, like to our sprites and so on. And so there's a lot of stuff like that we want to be able to do. And we want to insert fake lighting objects where the trees are, for example, that will catch light there. All that sort of stuff we want to be able to do. And we really just haven't thought that part through because for the most part, we've just been working on the light simulation part, which admittedly is the hardest part of the problem. But now we sort of have just the finicky part, which is the bookkeeping. How do we go from our scene to an understanding of where the light needs to be collected and what the occluders are, and then from that solution map it back to how does everything want to be interpolated. So since it's our first day back after kind of a big upset there, let's just take it easy. Let's take a quick gander at our OpenGL code. We've got our shader here, which is the shader for the Z-Bias program, which is the program that basically does everything for our basic rendering. And what you can see, this is the vertex shader. What you can see here is in the pixel shader is we have this sumLight function. And what the sumLight function does is it reads in a light count, it loops over the count of the lights that it needs to sample, and it integrates them, right? It basically says like, okay, well, integrates the wrong word. That's a mathematical term, I shouldn't use that. It blends them together based on their distance. So if I've got a few different light sample points that are being considered for this particular surface, what I'm doing is I'm reading in each light sample point, and then I am saying, okay, that light sample point is getting used in this way, right? And so you can see here it's taking the distance to the light sample point. It's using that distance as a way of determining how it wants the light sample to be computed. So you can see here, for example, it says, all right, I'm going to take the light distance x, the light distance y. Those are both encoded in the, the light direction x, the light direction y. Those are both encoded. I'm going to take the direction z, get that. Once I have that, I know which direction the light's coming from. I already have the position of the light. It's mentioned here. Here I compute the distance from the light to the place in the world that I am rendering, which allows me to know how to weight those light fall-offs. And then here I do the basically the fall-off with the normal, so I can tell based on the lighting direction that's being specified here, what my surface direction is versus that gives me the other fall-off term. And then I combine those together to get my final term, right? So that's what we're doing here. And there's a lot of ways that we might want to reconsider how this is working. So what's our main goal? Well, our main goal is to take a scattered set of lighting samples that we are computing, because we know we can't compute the light at every pixel, because you saw how expensive it is to compute the lighting in general. So we're trying to take a scattered set of lighting samples and take those and recombine them into something that allows us to shade our scene. Now, there was a couple of ways that we could do this, but they all have their kind of drawbacks. We started off trying a voxel-based scheme where everybody who wanted to do lighting would look up into the voxel and see what their lighting should have been, based on where they were in the voxel grid. I didn't love that system because it really ended up making the lighting be kind of too diffuse almost. And it creates problems where you're trying to figure out kind of what, it's just hard to figure out how to make sense of such a sparse grid of lighting data. And by necessity, a voxel has to be pretty sparse. Three-dimensional data can't be very dense. If it is, it rapidly overwhelms memory and processing power because 3 dimensions is a cubed problem, right? It doesn't take a very high dimension number for something cubed to become intractable quickly. Something squared is pretty bad, something cubed is even worse, and so that's why it seemed like that would probably be a bad idea. So what we decided to go with instead is a system whereby everybody in the game kind of knows what lighting sample points they're actually using, and those lighting sample points are kind of inferred back. So any given element knows which lighting samples it should consider when it's reconstructing its lighting. Now, this has positive and negative aspects. The positive aspects is we can have complete control when we create a scene to place lighting sample points and then gather them for our surfaces. The problem that we'll have there is that we can't handle dynamic entities as well as we might like to. And we're going to have to figure out how we want to account for that problem. So let's go to the blackboard for a minute and see. Now I could use some liquid. Hold on a second. I want to see if there's any liquid available. It turns out there is. I do have some sufficiently watered down lemonade, which will be perfect for this. Sorry, my throat was getting real dry. Too much talking. All right. I'm going to bring up Milton here. And this is going to be... oh, you know what? We lost our little day number because we had to reboot the system, and it's not in the startup sequence. So let's try that again. Is it 4:42? Is it 4:42? Miblo would know. Miblo, what day is today? Four 42. 442. So essentially what I'm talking about here is, you know, we've got things like a wall. And what I would like to do is place sample points on the wall in like this kind of a fashion, right? So rather than placing 4 sample points per plate, I would rather place 2 sample points along the seam instead of 2 on either side of the seam for each plate, right? And then I would like these to sort of interpolate together. You know, that'd be my preference. Now, there's a number of reasons why this might be a problem, but I think that generally speaking, if we create worlds like and have the worlds just kind of work like this, I think we'll get away with it most of the time. So I think what we can do is when we're creating our stuff, you know, we know the game will know when it creates a continuous wall, and it'll just place lighting points along the wall, you know, like this, if this is top down, right? If I'm creating a dungeon area like this sort of thing, right? And it'll just know to place the lighting points like this, and then it'll just, you know, assign this face to these 4, this face to those 4, and so on. So essentially what we want for all of our scenery is the ability to share these lighting points in that fashion, right? I think that's what we basically want to have happen. And so what we want to do is tune our ability to specify lighting points in that way. Now, I think that will work. It'll take a little bit of finesse to make sure that we do it just right. So there's a little bit of finesse involved in making that work efficiently. I'm guessing what we'll probably do, because I don't think we want to use a lot of indirection in the pixel shaders, is we'll probably do a forward copy pass. So it actually probably, you know, it'll probably be more like having these points be in an array where there are 4 unique points and then 4 more unique points. So this plate is reading from those and this plate's reading from those. And probably what will happen is there'll just be one forward pass before we start rendering the scene that copies the result from, say, these 2, and the, you know, the lighting system will only compute 2 points, and it'll broadcast those results out to the more complete texture, right? So I think something like that will probably happen to avoid using lots of indirection in our shader, which wouldn't probably be great. So I think that part is pretty reasonable. So for our flat walls, I don't think we're going to have a huge problem. I think we can make that work fairly cleanly, and we'll see how it goes. What is more troubling to me is the individual elements running around in here. So for example, you know, we've got a couple different things. We've got those trees, right, that are in the game. And then we've got like the hero who's in the game, you know? And so the question is, how do we light them appropriately? How do we deal with that? And to my mind, probably what we want to do, right? We need to put an occluder in. So we need to put a synthetic one of our light blockers in there. And that's probably going to have one plate and one sample point, per direction. So that'd probably be like 6 sample points and 6 faces for occlusion, right? And yeah, so that'll be 6 sample points and 6 faces for occlusion. And those faces for occlusion will just be there to make it so that things get dimmer where people are standing, right? Which is what we want to have happen, right? They're taking light out of the system at that location. And the thing that I want to focus on then is, so once we figure out what's going on with that, once we figure out what these lighting values are, we then need to write those lighting values into something that can be used to light one of our sprites. And so at first, I think probably what we'd want to do is just light the sprite by using these lighting values to just maybe just pick this one and use it at first, or, or average these together, like this one, and this one, or whatever. And then eventually, if we ever have normal maps for our sprites, for example, we could use the normal map to figure out which direction we're closest to and blend between them that way. Sort of use this almost like a cube map with 1 pixel per face, right? So that's probably what we'd want to do for those. And the only thing that worries me about that is the number of them that we're going to have, because it really increases our occlusion level pretty dramatically. And, I don't know how problematic that's going to be in terms of proliferating the number of occluders that we actually have in the system. But the point I'm trying to get to there is, as you can kind of see, there's 2 very different, oops, so I dropped that. There's 2 very different types of things going on there, and we have to kind of think about how we want those to work. Now, one of the things that's particularly one of the things that's a little bit questionable there is, do we actually want to do it that way, or do we want a sparser method or a different method for lighting things? Because, for example, one thing we could do is say, look, we don't even consider movable objects at all in the system. Or I shouldn't say movable objects. We don't consider sprites in the system at all. They just don't participate. Instead, what we do is we use some lighting points that are in the system at wherever they're near, and we map them to those lighting points, right? So one example would be, let's suppose that we took a rectangular area that represented the world here, and we just have, some trees around the outside like we do right now, or whatever's going on, and maybe there's a wall here and a wall here like we have. And we scatter some lighting points around sort of the general vicinity, and those lighting points just go into a spatial hierarchy that we pull from when we want to light a particular person. We know where they are, and we just grab the nearby lighting points and assign those lighting points to them. Right? So it's really just, again, another form of broadcast. It's saying, look, we're gonna compute a standard distribution of points for lighting throughout the scene, and that's all we're gonna do, and off we go. So, and that would work fine with the system as we have it now, because right now our system has the concept of a gather, and that gather doesn't have to be hemispherical. We can have spherical gather. So we can have points that are spherical gather points that are just strewn throughout the world that just gather what the lighting is at that point, and then you're done, right? And maybe that's a smarter way to do it, because then we just have a fixed number of points strewn throughout the world, and people hopping around in the world just get lit by those points, right? Again, really don't know what the right way to do it is. I'm just hypothesizing here some of the ways in which we could make this work. And I think that the interesting thing, the reason that way may be useful is because it doesn't proliferate the number of things based on how many entities are in the scene. So it's a fixed cost to do for any scene, whether you've got 100 entities in it or 5 entities in it. And all you're paying different is just the spatial lookup per entity to figure out what points are nearby, which isn't a very hard thing to do by comparison to throwing more and more points and occluders into the system for every entity. So, that's about all I can really say about that. I don't have super strong feelings about it one way or the other. It just, sometimes it behooves you to pick algorithms which have a flat performance profile like that, because then you know once you get them reasonable, that's just the quality level and performance of the algorithm, and you don't have to constantly be worrying about it limiting your game because the game now can't add 100 entities to a scene because all of a sudden you know the lighting will roll over and die. Even if the rest of the game systems would be just fine with 100 entities hopping around, you've introduced this really nasty dependency on a really difficult problem that you know you won't be able to improve. So that to me sort of argues in a gameplay sense to avoid constricting what is possible in the game and what we might want to do there. That does kind of suggest for that sort of loose network. So I think, putting all of that out there on the table, I think probably the way that I would look at it is very specifically to say, oh, you know what I just forgot to do, by the way? I don't know how to start the session again. We're so far off a session. All right, well, we'll just leave it for now. I should have a thing that says, like, put the little blocker up. Just do it. So anyway, I think that just to me says, okay, based on our experience of lighting so far, we know it's hard. We know that we have to do a lot of approximations. We know that we can't throw in points ad infinitum. We can definitely speed it up a lot more than it is now, but there will be a limit to how much we can speed it up. And there also are quality implications potentially involved in any speedups that we do. So that to me says maybe what I want to do is try to do something where we just distribute out a network of points, hemispherical points and spherical points potentially, so we've got 2 different kinds of points. And those points capture the lighting information with the system that we have currently. And then we just do a distribution broadcast out to the lookup parts for every one of our elements in the system, and off we go. That's all I got. That's all I got for you. I don't know how you feel about it, but that's what I'm thinking. And so I'm going to go ahead and try that, I think. Just let that be the first thing that we kind of work with. And I think to a certain extent, what that means is that we can really simplify the way that we're doing the lighting in the pixel shader right now. Because if you think about what that means, we can probably make it so that the lighting kind of comes in a much more coherent fashion where it doesn't have to do scattered interpolation, which allow us to make our pixel shader much faster and possibly just pass data at vertices and leave it at that, right? Because as long as we interpolate the lighting information rather than the lighting solution across our triangles, we should be okay from there. So I'm just going to hypothesize that all of the things that I just said are true, even though we have no real way of knowing whether they're true. And that's how we're going to proceed to try and get down to a nice shippable lighting solution that we can use for our game. And like I said, I'm pretty happy with where we ended up with that. It's kind of cool looking, in my opinion. And I think it's going to be pretty interesting. So what I'm talking about here is basically inside this SumLight function, what I'm basically saying is let's stop doing all of this nonsense because it's just too complicated. And it's going to cost us a lot of time in our pixel shader, and we really don't want to spend a lot of time in our pixel shader if at the end of the day, we don't really use that information as much, right? So what I want to do instead is I want to focus on a way to get this to be more vertex-based. And so what I'm thinking here is we'll basically take our vertices and we'll pass in, along with our vertices, we'll pass in the lighting information at the vertices because that's sort of how we're going to be strewing them about. And like I was saying, we just don't have the ability at this point to really generate dense enough lighting samples anyway to care about getting lighting samples in the middle of triangles and stuff like that. So what I'd rather do is figure out a way to pass down something like that. Now, granted, one thing that is true is saying vertices is a little bit difficult, perhaps, to process properly. And the reason that I say that is just because, well, you know, if you think about what's happening in this environment, you know, if I have two cubes next to each other, say like this, when I'm drawing these cubes, the place where I want the lighting samples is like here. But the vertices are actually here, right? So it puts us in sort of a difficult position because what it means is that these are not really vertices. So part of the problem is we do sort of want to pass additional information so that we know how to do our interpolant properly, right? And what we will end up with there, I think, is we just need to know for this face, we just need to have some information about how we want to render it. We still need to know the locations of these things that we're interpolating between. And so that's kind of, it's not as simple as passing information at the vertices that's literally interpolated along the vertices. So that may argue that we still want to pass it as part of a texture that we look up in the pixel shader. It's hard to say, right? We could still pass it at the vertices, but then use the additional information that's supplied as part of it to figure out how we actually want to do the interpolation. Or we can do an extrapolation where we just figure out what the values would have been at the vertices in order to produce the interpolated point that we have. So for example, if we know that we actually want the point to be here, but we know we're going to be passing something here, we can just take whatever value this was and take the inverse of the linear blend that would happen between these two to figure out what we should pass this as. If we assume that we pass down full floating point values, that's probably fine, because we could always pick values that would work. But it feels a little touchy to me. The reason it feels a little touchy to me is because interpolation is always very well behaved. And extrapolation, even when you're extrapolating to know that you're just producing an interpolated value, can get kind of numerically unstable in that way, depending on what the delta is that you're trying to reproduce between the 2 points. I feel like this is especially dangerous when you consider that we're trying to interpolate something, one of the components is a direction. So ideally, I think what I'd like to do is be able to pass down 4 lighting points in addition to the 4 geometry points. And I would like to interpolate between them bilinearly. I think that's what I would still like to do. Now, that's a little bit harder to do than we would like, because now what we have to do is like sort of reverse figure out where we are among those 4 points. But I don't really know that that's all that problematic, right? It's really hard to say. Let's try playing with a few things first. So if you recall, one of our big problems is that our pixel shader is too slow, even at the moment, because it's doing a nasty loop and all sorts of things there. And so one of the things that you can see in sort of or at least that we were getting before, maybe this is not happening anymore. In fact, it isn't with the new driver, it looks like. It looks like we maintain 30 frames a second now, because we didn't used to, right? Did they fix something? Because I feel like we used to have a problem where we wouldn't hit 30 frames a second if you were actually getting some pixel shading. I feel like they may have like fixed something in the pixel shader compiler or something. Because didn't we used to shoot up to 40 milliseconds? I really thought we did when we were doing big fills there. So I don't know. Maybe this is a bad extrapolation to make. Anyway, I'm going to go ahead and start cleaning some of this stuff up. But I wanted to talk about that lighting a little bit there. If we just assumed that we were only going to do a couple little things with the lighting, I wanted to see how that would affect the performance. But if the pixel shader is no longer actually causing a performance problem, then this is kind of a little bit academic at that point, because it was before, and maybe it isn't now. But anyway, so let's go ahead and take a look here at what we're sort of looking through. We kind of have a lot of test code going on here, and I want to kind of get some of it out of here at the moment. So we've got this point distributor drawing thing here. I'm going to get rid of that now. So we'll get rid of that little yellow blossom that we sort of created in the middle of things. Okay, and there you can kind of see, so no, you can see it happening, right? Now you can see that time delay I was talking about. So maybe the blossom just had enough, added enough additional draw calls to make it always slow, right? But now we're down, you can see the effect of the pixel shader there, where like we zoom in and we're getting 30 milliseconds per frame-ish. We zoom out and we're getting 20 milliseconds per frame. A pretty, you don't even need to measure it with with any accuracy. You can see what a difference that's making. And again, the lighting is not changing here. That's just reconstruction of the lighting in the pixel shader that's causing that problem, right? That's what we're seeing there. So if we wanted to play around with that a little, like I was saying, I'm interested to know what happens if this is no longer a loop. So if in here we just assume that the light count is always 4 lights, I'm interested to know to what extent the optimization would get better, or what things we could do if we just know that we are always going to fetch 4 lights, right? So yeah, if we just said light count, where is frag light count? Frag light count. Frag light count is here. You can see frag light indexes there. That's where we're starting to fetch from. So if I just set that instead to frag light count equaling 4, I don't suspect this will be much of a difference, but I just wanted to see if it changed at all. And oddly enough, even just that change does make a difference, right? I don't know if you can see that. But even just that change knocked about 2 milliseconds off the time, right? And so again, I think regularizing this code a little bit more would be good. So you can see us doing our texel fetching here, where we do a texel fetch with the light index, and those light index go in order. We fetch from the 2 different light samplers. And so one thing we could do, because we sort of know what those we know that those 4 light values that are coming in here are values that we want to interpolate. We could probably do something a little bit more clever, where we just let the regular texel fetch figure this out for us, right? So, just pretend we're doing this, right? So what we're doing right now is we're packing 4 of these in like this, right? And so what we have to do is fetch this one, fetch this one, fetch this one, fetch this one. and then we blend them together. But what we could potentially do, right, another option, is pack those like this, have a U and V value that we use that does this for us, right? So set U's and V's on these vertices that say how we want to sample. So for example, this U, V value or whatever, this would be 2, and this would be 0. So that it would run from 0 to 1 right here, and then just to 2 there. That'd be very well behaved, and it would clamp right here, which is what we want it to do, at the sample points, right? And then we could just align these points into that texture such that we could just use the regular bilinear sampling to blend these together for us, right? So we could potentially speed this up a bunch because we know we're just trying to interpolate a region. Well, what if we just made that region be more sensible? Right? Seems like a pretty sane thing to do. And then we could interpolate the things together. Now, it's a little bit harder than it sounds because, again, we sort of have this nasty issue where because we want to do the interpolation ourselves, because we are encoding the values in a particular way, interpolating the values ourselves might be more difficult. But I don't necessarily know that it would be, because this light Z reconstruction I think could happen either way. And so, yeah. I guess what I'm saying is the problem that we have here is just looking at whether or not the light D value is positive or negative. That's the one thing that stops us from using a built-in interpolator there. Because that's going to oscillate, because it's just encoding. It's doing an encoding of a negative value for the reconstructed square root. So yeah, that is a little bit nasty, but actually it's not that nasty, because if you think about what's going to happen here, if you pass those U and V values, you don't need the light position anymore. At that point, the light position, color, and direction, actually, we can just encode this stuff directly at that point, I think. Right? Really wish I hadn't run out of lemonade. So if we take a look at what we're passing down here to the renderer, in terms of those textures, we were encoding this as the position XYZ, and then the direction X and direction Y, and then the color was in here. But if we wanted to change the way these were encoded, well, we could do that pretty easily, right? You could see us doing a different encoding that looked like this. Actually encode the full direction, which would allow us to do spherical samples as well as hemispherical samples, and interpolate them properly using automated interpolation, right? As if that was an RGB texture. And then in here, we would just have the color. So that would be direction and color both encoded. And those could be encoded more concisely as well. They could be encoded instead of as floats as 16-bit values, for example. And that would give us probably plenty of material there. So you could imagine using these two as just an encoding of the lighting input at that point. And then each of our vertices would just have its UV value into its light region. And that would be it. And that's pretty straightforward, I think, for us to do. It's something to think about. I think that would be a pretty efficient way to do it. So I'm not going to start with that. Because I feel like that's maybe taking too many steps at once, and since this is GPU based, where although we do have a nice new debugger to play with, which maybe would make it a little bit easier on us, you typically don't want to take too many big steps because it's very hard to get into the data and really see what's going wrong. So what I'd like to do first is maybe change this sum light into a thing that's doing UV-based interpolation, for example. I think that would be a more useful thing to do. And we'll get that working first. Then we will go and try to encode the data more compactly later on, right? So we'll start by removing px, py, and pz from use. So we'll get them out of the equation entirely. And then we will go and re-encode once we know that they're out of there. And yeah, like I said, we can move to this sort of encoding. And whether or not, you know, we can also, the other thing we can do is we could normalize this vector. So what we could do is use the length of this vector to tell us something. So for example, this CRCG-CB, we could store this 8-bit. And we could make this dx, dy, dz be like color intensity. So then we only need one non-8-bit texture. Like this would be an 8-bit RGB texture, and this would be an actual floating point or 16-bit higher dynamic range texture. And then we're not wasting all of the information in there, right? Because you only really need 2 values, like I said, but because we need to interpolate and may want to use built-in interpolation, you know, it's hard to say how we want to do that. So we'll see. At the very least, this texture would be pretty easy to do automatic interpolation on, because of course it's just color. And we definitely could make it just do 8-bit there. Although, well, yeah, you know, now that I think about it, even that doesn't really thrill me, because if you want the interpolation to work right, if these are supposed to be values that get, you know, arbitrarily high, then when you interpolate between them, you need to make sure that the interpolation takes in that difference in size as well. So yeah. I don't know. We don't need to think about it too hard just yet. Let's just focus on the basics. All right. So in here we've got a smooth in vec2 frag UV, right? And we're going to need additional information beyond that UV. We're going to need like a lighting UV, if that makes sense. And so, yeah, when you take a look at what one of the vertices is, it's right here. This is not going to require a light count anymore. We're just going to say that the light count is out of the picture. But in here where we're passing the point, the normal, and the UV for the texture, we're also going to want to put a UV in there. So although we're removing one U16, we're going to want to add back in a UV for the lighting. So there'd basically be like a light UV. So, you know, we're sort of expanding a little bit from what we had before. And the emission value for this vertex, I don't know what that was for. And I feel like that isn't necessary anymore. Is that even getting used anywhere? Hold on one second before I do this change. So it's not. So let's just go ahead and remove that right off the bat, because we don't need our emission values go into the lighting system. They don't go into the vertex stream. So let's just get rid of that emission value altogether, because it's simply not relevant to the way we've structured our system. That was sort of an old part of the process that no one cares about anymore, and so we might as well just get rid of it. So now if we look at how this is laid out, we have our p value, which we really can't touch. We have our n value, And our n value, at least at the moment, really doesn't vary. It's actually constant per primitive. But that may change when we start doing more stuff with our sprites, so it's hard to say. I strongly suspect that this probably, for all intents and purposes, that probably can be moved down here. So I suspect that we could have a per primitive buffer that specifies normals, because really it's just the P and the UV that we really vary, and the color, but not the normal. The normal just points in a direction, and then it doesn't really do anything else. So yeah, if we look at how much is being spent up here, you can kind of see that if we were to do this, what we end up there is there's probably just way too much accuracy being specified in these two things. Floating point values for these really just probably aren't necessary. So these can also probably be compacted quite a bit. 2 8-bit values for the light UV would probably be plenty. And probably for this UV as well, because we tend to only use like whole sprites. We don't really have much packing or anything. Maybe in the future we would. But these actually could probably be 16 bits each, honestly. So we could get this down to quite small. One problem that we would have there is I don't know how good OpenGL is at accepting normalized UVs. I think it's pretty straightforward now. It used to actually be kind of bad at it, but I think it's okay at it now. So if we wanted to, this could easily be something more like this. If that was something we want to do. And maybe that is something we want to do, so maybe we should try playing with that a little bit. Hard to say. Now, one problem that we will have is the light UV. This UV probably can work this way very easily because it's just picking out sprites. The light UV is probably not that way because it's got to do the sort of weird interpolation stuff that I was talking about before. So it may be that this one actually has to be, a real value to a certain extent. If we take a look at what we've got here, where we've got, this would actually line up pretty great. This would be 4 floats, 2 floats, and then essentially 2 more floats. So basically be the size of 8 floats, right? And so, if you think about it, a 32-byte vertex kind of fits really nicely, and it's nicely cache aligned, and everything's great. So, that might be a nice way to encode things if this turns out to be all we need to specify per vertex. And then this stuff down here is still aligned reasonably well and all that. The problem is that we really just don't want to specify this stuff at all. I think this stuff wants to be specified per vertex. I'm sorry, per primitive and not per vertex. So I think this is kind of extraneous and bad. But we can sort of cross that bridge when we come to it. All right, so again, if we take a look at how this UV stuff is working, yeah, so there's a couple ways we can do this. The other thing we can look at here with the UVs is say, look, the light index now can be rolled into these UVs, because if we're going to pack these into a texture, then what we can do is into the light UV, if that's a float, we can just pack that in there. So really, these two can go away entirely, and this would just have to be specified per vertex, right? Yeah, and that'd be that. So at that point, again, I'm not sure, I'm sorry, per primitive. And I don't really know whether that makes sense to do or not. It might be that that's just slower, and it's just better to bloat out the vertex with it, I don't know. All right, anyway, enough hemming and hawing about that. So that's basically what we'd be doing here. So if we take a look at this, what I'm interested in doing here is making the light UV maybe encode this value. So the first thing I'm going to do is I'm going to get rid of light count because we don't need it anymore. And you can see here we're passing that as an array, and we just don't want that anymore. So I'm going to take a look at all the places we were doing that. We don't need this vert light count thing anymore. And in theory, that should do like absolutely nothing differently, right? It's just the same stuff, no biggies, right? And we shouldn't see any deleterious performance implications from that, and we don't because we're just removing things, right? Okay, so next step. What I'd like to do here is figure out a better way, again, of accessing these textures. So what I'm thinking about here is this light UV value. Can we use that to just pick out the information we need? And so what I'm going to do is I'm going to say, let's maybe stop with the light index part of things and instead just use the light UV to figure out that value, right? So yeah, this requires passing the light UV down. So we're going to need a way of passing that information to the shaders and interpolating that along as well, right? And I guess one kind of nasty aspect of this is that so maybe we want to do this in the opposite order. Maybe we want to pack these into the texture in the order that I was suggesting they should be packed. And then still use the index, the fetch shader, to do what we want it to do. So for example, inside some light here, you can see doing light I. It starts at frag light index, and it increments, right, and does this whole thing here. So probably what I should do is convert this to something that just does the fetches into a texture that is laid out the way that I suggested, so 2 rows instead of 1. So basically it fetches things that it knows are supposed to be bilinear blended instead, right? So in order to do that, what I would have to do is sort of convert this blend call into something that does more of a parameterized version. So if I took this out, and I made this call right here be something more like fetch and sum or something like this. So what it's going to do is this is going to do, it's going to update this result value here. I'm not sure how you pass something to be modified in a shader like that, now that I think about it. My shader coding skills are poor, to say the least. I usually look up everything as I go. What I could do here is just do actually just like this. So what I could do here is just say, well, you know, the running sum value, like we'll set to 0 here, and then we'll just call this 4 times. So in here, we want to fetch these 4 light positions. We don't need any of this stuff really. In fact, I can probably just get rid of light I altogether and just say, look, it's this. Do 4 of those sums. They'll sum into running sum. And then here we'll just say result equals running sum. So that is the, yeah, I'm sure there's a good way to pass something into fetch and sum. But I don't know what it is. Anyway, so then we'll do our 2 textile fetches. We'll do all of our computations. We don't need any of this stuff. And that will update running sum with the value that we actually wanted. And from there, we should be able to kind of go forwards with starting to make it fetch in a different way. So here we are doing our lighting again. This time we're doing it with those calls instead of the loop, right? And again, no real problems with the performance compared to the old performance, so we're not changing anything drastic. So now, when we do this textile fetch, and we're doing this sort of summation here, now what I want to do is sort of change this over to something that's going to do, again, like I said, a sort of a bilinear blend. And so what I'd like to do is make it so maybe so fetch and sum is not really fetch and sum, it's just like fetch sample or something. And we can fetch the 4 different samples that we want separately and then use them, right? Now the problem that I'm going to have here is that, again, I don't really know if we want to do this way because we probably want to let the automated summation stuff in the bilinear blend, in the textile fetch bilinear blend, just do it for us. So I mean, it may be that we really kind of have to make this jump all at once. No, I mean, I think we can still make baby steps. So let's suppose we leave this as fetch and sum. Oops. If we leave this as fetch as sum, suppose I just update these 2 and we pass in the right values here, then we should be able to update those textures to have the things in the order that I suggested before. And then it should be fine. So I think we can make this work in smaller steps. Right? So let's just double check and I'll see if that's true, because we're almost out of time anyway. We got like 15 minutes left, I think. Again, that all still looks pretty accurate. Kind of weird. One thing that's doesn't make a lot of sense is why that is getting lit. I mean, I suppose that those points are getting light on them, but yeah. I guess as we start to spread these light points out, one of the things we can do is start to debug some of those things a little bit better. Because right now, the way that we're doing light placement on surfaces is also a little wonky. And so sometimes I can't quite guess if something's a bug or not. And we need better ways of identifying whether things are bugs for stuff like this. Really liking this lighting, though. It's so pleasant. Anyway, so yeah, what I'm interested in doing here is turning these into 2-dimensional samples that we can use the UV for. So what I want to do, right, in this case, is I want to kind of take this and turn it in, as strange as it seems, turn it into that, basically, where we are sort of, putting those for the primitives, we're having like 2 rows of light information, and we'll sort of distribute the light information in there proportional to how we want to interpolate it. Now, light data width is kind of a stupid name now. And furthermore, we really don't need these to be shaped this way. They could be shaped in any way, really, because if we actually make a light UV, then basically we just have a light map and we're putting things into the light map. And, that's just, yeah, it's not that complicated of a thing to do, and we pretty much could use a square texture. We don't need a rectangular texture anymore for that purpose. So that part's a little bit jankier, but we'll do it one step at a time, again, to avoid anything that's going to be too deleterious. So if we take a look at this here, if we expanded these light data to be stepped in this fashion, then what we need to do is we need to pack those in there in a way that will make sense for fetching them out later. And so what I want to do is when we go in and in the lighting routine, place the actual data in there, as you can see here, what we're doing is we're placing the data into this point index system, where as we run through, we know that every point index in the system corresponds to one entry in the lighting setup. And what we'd like to do instead is have a more coherent notion of where these points actually get packed into where they actually get packed in the texture. Now, one thing I could do, again, to make even more baby steps, is if I just leave it the way it was, and instead introduce some notion that the packing has to get packed prescriptively, then when we're looking at these lighting points here, what I can do is say that there has to actually be some information for a given lighting point that says where the lighting point is supposed to actually be packed, right? And so if you take a look at how these lighting points get added in the first place, what you can see is that when we run through here, we go through each of the boxes that we have, and each of those boxes then gets a point added to the system as such. And so what we could do here is say, look, since we know how we're placing these points relative to the boxes that we're creating, we should then also be able to say for each one of the points where we want it to get packed back to, right? So for example, in here we could just have an integer that's like pack index. And when we specify in here what we want to pack, we just say that like point pack index equals something. In here, when we're doing the points, we know how many we have, so the pack indices should always be valid. And what we can do is say, well, all right, at the moment we know that the pack index is just going to be the same as the point index, right? So there really isn't any difference between those two things, and they can just be packed directly. And then when we come down here and we're going to do the packing, normally we were saying point index before, but instead what we're going to do here is have a pack index. What we can do is take the actual piece of point information, get that out. And then in here we can just say, okay, point P, point N. And we're still doing the stuffing here, and again, that's going to be something we want to sort of, when we start looking at the normal information, we're going to want to stop doing that. I recall it didn't change very much, but it might change more as we start to distribute our points out in different ways. So what we want to do again is just say, okay, now when we go and pack these back, we want to use the pack index here. And again, that's just going to be given off of the point. Oops. What am I doing there? Yes, that was totally wrong. And so now we're just packing back at a place that we've specified, and at the moment that doesn't do us anything. It's the same as it was before. But as we move forward here with doing stuff where we've got a more coherent notion of how these things should get spammed back into the textures, we can get more aggressive with that, right? So now if we take a look at these pieces of light data, let's go ahead and do the thing that I was saying before, where we say, all right, let's pack these into 2 rows now. So there's like, they're kind of in more of a UV pattern. And what I'll do there is just say, okay, we've got 2 pack indices, let's say. So maybe this is a pack row value, and that's a pack index value. And then what I can do is say, all right, if I know the pack index and the pack row, I can put these into the textures properly. And then what I can also do is when I'm submitting these textures, I can then start thinking of them as things that could be interpolated between by using a bilinear sample. As long as I pack the pieces of information in a known orientation that makes sense for the surface. So now when I come back here, what I want to do is be a little bit more prescriptive about, or specific about how these are getting packed in. So if I have a row index and a pack index, what I know is my row index is actually given by one of these because I've got an X sub and a Y sub. So what I could say is, well, my row index maybe is my Y sub value, so I have 2 rows that I'm packing into. And then my pack index for X is going to be whatever the light index is, times 2 since I'll stride. And we don't really want that actually. I guess we want an actual value here, but plus my Y sub. So I know that like I pack 2 values in for every square, right? Because this is a square of a square sample pattern. So I just want to do 2 rows, 2 columns, right? And then we just say, okay, my pack index, right? Oh, so yeah, this actually gives me roughly what I want here. You can see that we get this box light index value. So I could just use this value, and that would actually be fine for the moment. So yeah, hard to say what I want to do about that. So the reason that that's a little bit wonky is just because the line index that's coming down here is kind of separate from where we might want to pack these into the texture. This light index goes up by 4 every time because there are 4 lights. Well, no, sorry, it's more than that, right? There's 4 per surface. So it actually goes up by 24 points per box at the moment. And we don't really need to obey that at all when we're doing our packing because we've got 2 rows to pack into. And we're going to have a lot of other packing concerns involved. So there's kind of, yeah, it kind of fights this a little bit. And the way that we're doing these submissions, again, I think needs to get cleaned up. I don't know if you remember what we kind of were saying that this stuff needs to be moved to the world generation stuff anyway. How these points get distributed. So it's kind of a little bit of a mishmash. Yeah, it's kind of a little bit of an issue there. So I'm not sure exactly how I want to do that just yet. Like I said, this part's all going to be finicky bookkeeping. That's really all that's going on here, is figuring out the most efficient way for us to do this sort of stuff. I can just use the light index here, probably. The base light index. Yeah. I mean, like, for now, I can do that. But admittedly, it's not great. We kind of need to start lofting this out to a higher level, right? Where, because the distribution of points is not going to be one-to-one with the blocks that it uses. Although, again, we could kind of, yeah, well. This requires some thought. So I'm going to back this out for a second. Leave this the way it was. And I think this is where we'll pick up tomorrow. Because what I want to do is I want to figure out the most efficacious set of steps to make here. And I think what we might want to do is go into the WorldGen code and actually figure out how we want to generate the information about how these things go together. Because there's two ways we could do it, and one of them is to leave boxes and light sample points sort of aligned with each other. And maybe we really want to do that and then just apply a blur. Right? Like, so, you know, maybe a different way of looking at this problem would be, maybe we want to sort of sample the lighting of these faces just as faces, and then have a thing that operates after the fact that tries to produce what these 2 points should be based on the lighting here and here, right? So I kind of want to think that through a little bit more. I don't want to do that at the end of the stream because we only got like 4 minutes left. So I think what I'd like to do is that's what I'll pick up on tomorrow. Let's go make something that actually generates like, you know, a wall and places the points where it will, and just tries to figure out how that forward bookkeeping is going to work, because I feel like we need to kind of push forward from that. So we'll do that way. I think that's the right call. So let's go ahead and go to, let me just make sure that we left this in a good state. Let's go ahead and go to our brief Q&A. Hi, Casey. Can you please remind the good people on the stream, 1, why templates are bad, 2, what use cases templates can be considered for, which they are good and bad for, and what they can be replaced with even then. I'm going to take a gander. It's metaprogramming. Yeah, so let's just see if we have any on-topic questions first, because that was not really a topic of today's stream. If we don't have any other questions, I'm happy to fill the 15 minutes with that. But it's not really apropos, if that makes sense. Frosty Ninja, has getting Nsight working boosted your morale back and recovered some hope? Well, yes and no. I mean, I would say not really, and the reason for that is just because it was very depressing to have the whole thing the other week where it's like, okay, we couldn't even get NVIDIA's website to work and whatever, and that's true. And that sucked and all that, but on the whole, most of my experiences in the past with NVIDIA have been good. When I try to talk to programmers there or driver writers there to have them do stuff or help me with something or fix something, I have generally found them to be easy to work with. So I wasn't like super down on NVIDIA or anything. So in some sense, the fact that they, specifically took the time to come and ask me if I needed help on getting this going, while I'm really happy they did that, they tend to be good like that. I generally have positive experiences working with NVIDIA. And so I wouldn't say it boosted my morale all that much, because really it just reinforced what I already thought, which is that if I'm really in dire straits with something NVIDIA related, I'm not that despondent because they seem to be pretty good, right? If they hadn't, and if we still couldn't use Nsight, maybe I would be in even worse mood. But generally speaking, NVIDIA is not the primary problem when I think of people who don't care about developers. It's not NVIDIA, right? NVIDIA, among the folks who developers typically have to deal with on a day-to-day basis, they are probably the least problematic in terms of actually getting them to pay attention to problems and help with them. And they certainly tend to ship some of the more stable drivers and tools and stuff that I use. I don't know how to put it any more specific than that. Am I still moving to Montana? No. Do you have any plans for doing shadows in the game? No, I don't really want any shadows in the game. Not hard shadows anyway. There obviously are shadows in the game already, in the sense that when you move behind things, you do get shadows, right? So that's the shadow of this wall. That's why it is not there. So we actually have pretty advanced shadowing. Very advanced shadowing, in fact, at the moment. What we don't have is hard shadows. So, and I don't really want to do hard shadows. I don't like hard shadows. One thing that's kind of weird about the way people do shadows in games is, like, if you look at games generally, once the game gets to a certain level of graphical complexity and quality, oftentimes you can't see shadows anymore as such. So, for example, if you look at a game that looks really good, to pick one from recent memory that I thought looked quite good, if you start to look at these, the shadows sort of start to become fairly irrelevant. So you look at this scene and you're like, well, there's a little bit of a direct shadow right there, and everything else is indirect lighting, right? Like you just don't see a lot of contribution of the direct shadowing to the overall quality of the scenes, right? And so you look at this stuff and, you can see these sorts of pieces here as this is the direct illumination pass that's doing that right there. It's just not the most important part, right, in terms of the character. Again, you kind of look at something like this, and it's just, I can't even really see the direct shadows here. I guess it's that part. This is Assassin's Creed all of a sudden? I don't know why we're also looking at that. And so I just tend to not think of it as that important, right? Typically speaking, if you just want to ground the player, just putting in a little bit of fake shadowing there tends to be good enough. And in our cases, if you think about how these are generally created, this is actually not that hard to do, creating these shadows, because it's typically a shadow pass with whatever your strongest direction of light is. We don't really have much of an option of doing that because we don't have real geometry for our stuff. We just have sprites. So our shadows would be pretty inaccurate as it is. So again, just putting in just a standard little darkening beneath the characters is all I really plan to do. And again, when I just look at these, direct shadowing just doesn't contribute that much, right? Typically what you see more is just the fact that the backs of things aren't lit brightly and the fronts are. And the directly cast shadows, really you just don't see much. I don't even see them at all here. I guess that's it right there. But if that wasn't there, I wouldn't even know, right? Like I wouldn't even have noticed it not being there. Honestly, hardly at all. In this scene, I think it's right there, right? Other than that, I don't even see any direct shadowing in this scene that really I notice. So I think like, and this is true of the real world too. Like, I mean, if you just look at photos, you just don't see a lot of that. I don't know how to get just random photos. So here's a shot. And again, if you look at what you notice in this shot in terms of direct shadowing, you know, all I see is some darkening underneath the elements, right? I don't see any direct shadowing in that scene. I don't see any direct shadowing in this scene. None in that 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 scene. I mean, it's just not there. So to the extent where we really need to think about it at all, I really think the only thing we need to worry about is darkening underneath, like where the player is standing, so they can see what they're standing on. That piece of visual information, the darkening, I think is important. Everything else, I think, is just a waste of time. Because real scenes just don't have a lot of like, oh, I see the long like shadow being cast. Again, same thing here, right? There's some direct shadowing happening here. It's just darkening where there is stuff. And I don't need, like, I can't even perceive that those are cast by this thing in terms of shape. I just know they are because there's stuff there. So again, it's just like, it's just a darkening that happens underneath stuff that can be easily faked. It doesn't really require any of that sort of solving. And so I feel like our soft shadows, plus if we want to darken something underneath things specifically, is really all we need. Is the cause over brightness merely a change in the algorithm makes the light brightness value different, or is there an actual bug? Well, again, the reason is just because we're doing an approximation of the integral, and we aren't approximating the cosine term correctly in either case, because in one case we're undersampling the hemisphere but correctly multiplying by cosine theta. In the other case, we're maybe sampling the hemisphere a little bit better because we're concentrating towards the points that contribute more, but we're undersampling the cosine theta part. So both of them are bugs in accuracy. They may not be bugs in the oops, we had a line of code wrong sense. So will sprites be simply flat lighted, or do you plan to implement something to give them fake 3D lighting? If we end up having normal maps as input, I don't know if we're going to have any normal maps for input, then we'll light with the normal map. Otherwise, we won't. Lucid Frost, how similar is this lighting model to something you would find in other game engines? It's fairly similar, I think, to what you would find in like a high-end radiosity-based engine. So I think it's fairly similar to, say, how the Frostbite engine does its indirect lighting pass, I think. So for example, is that what it's called? And I don't know, I have no idea how Enlighten works. I know literally nothing about it. So, you know, take this with a massive grain of salt. Because we are probably very different in terms of how we work than they are. But, so, Here's an example, right, of how their system works, sort of a little bit anyway. Here's the direct lighting pass from the engine, which they can do. We can't do it because for two reasons. One, we don't limit the number of lights in the scene. And two, they have real geometry, so they can do a real direct lighting pass, right? So they do a direct lighting pass, and then what they do is they take at various points in the scene and they record what the direct lighting was at those points, right? And then here you go. The main runtime operation in Lighten is to map a point sample description of the lighting over the target mesh surface, which is this, to a light map or light probe output. This is the bounce. Anything you can express in these terms is valid input to Enlighten, right? And so here's what Enlighten outputs. Now, looks familiar, right? Yeah? I mean, that's a lot like what we get, you know? And so then it goes ahead and reconstructs that in a way which is what we're working on now, how to reconstruct our version of this to something that's smooth for what we want. You know, I don't know how they're doing that exactly, but I assume they're doing it roughly how we're doing it. Directional irradiance, they put between first full spherical output for the spherical harmonics at a point, so, you know, who knows exactly what they're doing. But anyway, then they composite that with the actual scene geometry and they get that, right? So in terms of what we're like now, we're kind of just like a high-end radiosity thing at the moment. How well will that work for our 2D game? I don't know, but it's doing nice lighting distribution, so I'm kind of happy with it. Why use Nsight in the application for graphics debugging when you already use Visual Studio for CPU code debugging? Why not just use Nsight in Visual Studio? Because the Nsight in Visual Studio is really like finicky, and like I don't like having to deal with the same panels. I just want a thing that's like laid out for graphics debugging only and is optimized for that. So I would prefer an external tool if possible. And that's what that gives me. So I kind of like that. I know a lot of people like IDEs. I don't know why they like IDEs. I can't stand them. Typically, I like to have a tool for that job that I can rely on and works reliably for that job. I don't like everything crammed into one thing. And then it's like, okay, this view may be right for debugging, but now when I want to do Nsight, all of a sudden it's like jammed into it and weird, and it's using the same key combinations which are wrong for what I might want. I like having different contexts for different operations. I'm not debugging code when I'm debugging graphics, almost ever, right? Because they're just not similar. One is running on a GPU, one's running on a CPU, and only sometimes do the twixt meet. So typically I'm trying to do a specific task and I want something that's designed just for that task that I switch to and is optimized for that purpose, right? Have you considered baking shadows? We cannot really bake shadows in that way because we are procedurally generated. So we can do some baking of shadows if we wanted to have some static geometry or something, but I mean, but also the lights are all moving around. I mean, I just don't even know what that would mean, right? I don't really think you could bake shadows in this case. Do you think that the small number of the number of small draw calls might be causing GPU occupancy issues? Can't remember if we saw occupancy statistics in Nsight. So the small number of draw calls is going to cause a lot of unnecessary driver overhead, period, and we should get rid of it, and we probably will. So I would say it's not really necessary to look into it particularly much because it's just a unnecessary thing that I think I've decided I want to get rid of anyway. And so we probably will. Show what the game looks like now. Oh, were you not okay? I mean, we have been running the game when we've been testing the lighting. So this is our little test area that we're working on here, and we, you know, we're a 2D game, so it will only be visible from this perspective in the actual version of the game. But we can use the debug camera to inspect our 3D scenes pretty easily, like so, right? And so what we're testing right now is we basically just attach this light to where the player would normally be. And as you can see, I'm like moving it around to test the lighting because that's what we're working on at the moment. And so at the moment, we've gotten ourselves to pretty good lighting solutions that we've got right here. But what we haven't done yet is, and what we're now moving to work on, is we want to reconstruct our lighting in a smooth fashion. So, you know, the lighting right now is basically per block surface, and the block surfaces aren't shared together in a way that makes the lighting coherent and smooth. And so what we want to do is just make that happen. So that's the part that we're doing now. And you can also see out here, so the white blocks are blocks that are pulled into the simulation but that aren't lit. And so that's another thing that we haven't really done too much of yet, is determine where the lighting solution happens and where it doesn't happen. So we'll probably do a little bit more with that in the future as well. I'm going to go downstairs just because I can. Again, you can see I'm really happy with how this lighting is turning out. I mean, that just looks cool. You get this rim lighting here from where the light's coming from downstairs. Up here is all darker now, right? It's just really pleasant. And we do suffer a little bit from our approximations. You can see, like, probably that shouldn't be lit right now. But it is. And of course, the reason is because we approximate regional lighting and we don't do a whole lot to fix that. But I'm okay with that. You know, it's still, again, lighting, any real-time lighting is an approximation always. And you're going to get glitches. I don't mind those kind of glitches. I'm fine with that because it still does the right character, right? It still provides the character that I want in this case, right? So. All right, I think we're all done. Alrighty. Do you plan on having 3D objects for things like gates or doors? I just want blocks, and the block can have textures on the sides of them, but just blocks and sprites are the only two things we'll have. So in some sense, the doors will probably be blocks, which means they are 3D objects, but they won't be like special 3D objects. Like they won't be modeled in like Maya or something. They're just going to be blocks. So the only input to the game should be textures. There's not going to be 3D models that get input. If that makes sense. All right, thanks everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the game at home, you can always pre-order it on handmadehero.org, and it comes with a source code that I update every time we do programming on it, so that you can follow along at home and do your own experimentation. Maybe you'll figure out an interesting way of integrating the lighting before I do, if you are a intrepid sort of programmer. That's about it for today. I will be back here tomorrow when I will try to do a little bit of world gen code to see how we're going to place those lights. And so I'm going to try and start to streamline that process, because the very next thing that we have to do after lighting is probably start working on the world gen and art stuff to sort of build our worlds now, right? And actually get some worlds in there that we can walk around and really start to clean up the engine to the point where we're happy with it. Doing everything that we need it to do, because we basically like got all the components that we might need, but they could kind of benefit from now pushing forwards and seeing what's going on. And so we need to start pushing that. And so what I want to do is get the lighting tied into that part of the process. So I think that's what we're going to be looking at tomorrow. Hope to see you back here for that. Until then, have fun programming, everyone, and I'll see everybody on the internet. Take it easy, everybody.